Hi, I'm Jim Reese, Vice President of Agricultural Chemistries at Precision Laboratories. We're here today to talk about how we can use spray solution pH as an indicator of the impact that glyphosate has on our spray solution pH, as well as the impact that water conditioning agents have on spray solution pH and the potential performance of glyphosate. Let's start out by understanding what glyphosate does to spray solution. If you've seen other videos that we've done, you know that I like to use red cabbage juice extract as a pH indicator for my spray solution. Now, I've already prepared a sample of spray solution here, and as you can see, it's logging in at about a pH of 8. We know that glyphosate's a pretty strong buffer, and it can reduce spray solution pH. What I'm going to use now is a 41% generic glyphosate formulation, and I'm going to add it at the rate of 1 quart per acre. And I'm assuming that I'm going to be doing 10-gallon work. So this 100 ml sample then represents 100 gallons, and I would add at 10 quarts or 2.5 milliliters of glyphosate to this. So there's 1 ml or 1 gallon of glyphosate in 100 gallons of water. There's 2 gallons, and now there's the last 2 quarts, and you can see this starting to affect the spray solution pH. In fact, what we'll find is that glyphosate is a pretty strong buffer, and it lowers spray solution pH to about pH 5. So why is this important? It's important to understand this so that we make sure that we're adding the right tank mix partners to Roundup in the right order. But also, we're going to use this as a benchmark to determine the performance potential of water conditioning agents that we may add to enhance glyphosate performance. So let's compare the performance potential of 2 different water conditioning agents. We've got an ordinary water conditioning agent that I found in the marketplace being sold today in the Midwest, and FS Infix. Now, if you'll remember, I've got water that's already at a spray solution of pH 8, and what we're going to do is we're going to add water conditioning agent to each one of these samples. And what we're looking for is a pH shift. And this is a good indicator of the product's performance potential relative to its ability to tie up hard water ions, and potentially, if it can lower spray solution pH low enough, improve the performance of glyphosate. So let's add the ordinary water conditioning agent first. These materials are usually used at 1 to 2 quarts per 100, so common rate is 1 quart per 100. Let's add that to the spray solution and see what happens. As you can see, it reduced spray solution pH, and we'll take the FS Infix and we will add an equal use rate of 1 quart per 100 to that. And as you can see, both materials reduce spray solution pH from 8 down to what we believe would be an optimum range for enhancing glyphosate performance at about pH 3. Now, the problem with all this is we did that in the absence of glyphosate. So to really get a good idea of the capabilities of these materials, we need to add glyphosate back to the spray solution. So let's go ahead and add our 1 quart per acre of glyphosate back to the spray solution of the ordinary water conditioner. So we talked about that being 1 quart per acre, doing 10-gallon work, so we're going to add the equivalent of 10 quarts of glyphosate in 100 gallons of water. So now we're moving the pH back closer to the pH 5 range where it was originally at. And we'll do the same thing with the FS Infix. And we'll add the same 10 quarts